All right, guys, back again. All right, so these ones we take a look at today and tomorrow are going to be slightly different than the ones we've been working on, okay, because they bring up an issue that we haven't had to deal with up to this point. Now, remember all the other ones that we had, it was a constant over a quadratic. And so in terms of degrees, you had the degree in the numerator being a constant is degree zero, degree zero. And the quadratic down below was degree 2. So in terms of degrees, you had a proper fraction. You had the degree in the numerator was smaller than the degree in the denominator, okay, which is what we want. And here you end up with something where, in terms of degrees, it's sort of like an improper fraction. Notice how the degrees are the same, okay, and we can't have that. All right, so what we're going to have to do is we're going to have to do the division, okay, and change this into what amounts to a mixed number, okay? So I have to do this long division, which of course you know how to do. So we have x squared, okay, plus 0x minus 9, and that is being divided into x squared plus 0x minus 16. Okay, so we get x squared divided by x squared is 1. Okay, and so we multiply through and we get x squared plus 0x minus 9, and then we do the subtraction. Okay, so x squared minus x squared is 0. 0 minus 0 is 0. Negative 16 minus a negative 9 gives us a negative 7. Okay, now we expect to get a remainder. We know this isn't going to divide evenly. If it did, then we'd be able to just reduce it. Okay, so that means that this guy can be written as 1 plus negative 7 over our divisor, x squared minus 9. Okay, so this guy right here is the same as the integral of 1 plus negative 7 over x squared minus 9, like this, dx. And so see what happens is right here we get an expression, okay, very similar to the ones we were working on the last 2 days, where the degree in the numerator now is smaller than the degree in the denominator, and therefore this guy can be attacked just like we did the last couple of days. Obviously it's going to be really easy to integrate this guy. Okay, so this guy's easy, we're going to have to use partial fractions here. Okay, so let's see what happens here. Okay, so let's see. I have this integral of just 1 dx, okay, plus this integral, okay, and I tell you what, I'm going to take that negative 7 and move them out front. Minus 7, okay, and it'd be 1 over x squared minus 9, so we would factor that x squared minus 9 into x plus 3 and x minus 3, like this, dx. Okay, and so now we have to attack this guy right here. Okay, we've got to attack this guy using our partial fraction method. Okay, so let's see what we got going on. Okay, we'll get all the legwork done here, and then I'll get another sheet of paper. Okay, so I want to take this guy, and let's see, we have 1 over x plus 3 times x minus 3, and that has to be equal to some constant over x plus 3 plus some constant over x minus 3. Okay, so again, we multiply through by x plus 3 times x minus 3 to get rid of the fractions. Okay, so over here, everything cancels off. We just get 1. Okay, let's see. Here and here, the x plus 3's cancel, so I'll get x minus 3 times a. Plus, let's see, here and here, the x minus 3's cancel, so I'll get x plus 3 times b. Okay, now let's see. Just like we were doing yesterday, let's suppose if we get rid of this guy first. So I can make this a 0 if x is equal to 3. So when I let x equal 3, okay, I get the 1. I get a, this would be a times 3 minus 3, which is 0, plus b times 3 plus 3, which is 6. Okay, so this goes away, so I just get 6b equals 1, so b is equal to 1/6. Okay. All right, then let's do the same thing and let's get rid of this guy. So if we let x equal negative 3, okay, then let's see, we get a 1 equals a times, well, negative 3 minus 3 is negative 6, plus b, let's see, negative 3 plus 3 is 0. Okay, so this just goes away and we get negative 6a equals 1, so a is equal to negative 1/6. Okay, so let's see. I think we can get this set up now. Okay, so let's see. I come back up here, and so we're working with the integral of 1 dx minus 7. Okay, and this would be the integral of, what do I have, a over x plus 3. Okay, so it'd be negative 1/6 over x plus 3 dx. Okay, plus the integral, let's see, I have b over x minus 3. And b is 1/6, so it'd be 1/6 over x minus 3 dx. Okay. All right, so let's see what we got going on. And notice this whole, this whole thing right here is multiplied by negative 7. That's why I have these brackets here. Okay, and so we're in good shape here. Let me bump this guy up a little bit, and let's start there. And let's see what's going on. Okay, so let's see. Okay, I can easily integrate this guy right now if I wanted to. Okay, the integral of 1 dx is just x. Okay, so I've got that x. Okay, I'm going to distribute this negative 7, and I'm going to pull this guy down as a constant multiplier. So our negative times a negative is a positive. And then 7 times 1/6 obviously is 7/6. Okay, and then I would have 1 over x plus 3 dx. All right, let's see, I got a negative times a positive, so that's minus. Okay, and then I would have the 7 times the 1/6, so that's 7/6. The integral of 1 over x minus 3 dx. Okay, so I should be done with everything up here. I can just get that out of the way. Okay, so let's see. This guy is done already. This guy, we just have to use u substitution. So let's see, u equals x plus 3. So my du is equal to dx. Okay, so I'm going to bring that x down. Plus 7/6 times the integral, that would be 1 over u du. Okay, minus. All right, again, do the same thing here, use u substitution. Let's see, u equals x minus 3, so du is equal to dx. Okay, so I get that minus 7/6 times the integral of, that would be 1 over u du. Okay, so let's see, bring the x down, plus 7/6. Okay, the integral of 1 over u du would be the natural log of u, and u here is x plus 3, so we get the natural log of x plus 3 minus 7/6. Okay, once again, the integral of 1 over u du is the natural log of u, and here u is x minus 3. Okay, so all of our integration is done, and certainly this would be one form of the answer. I don't think it's a very good form, okay, but certainly that would be one form of the answer. Whether that's acceptable or not depends on who's in front of the class. I know me personally, I'm going to do something like this. That x just stays out front. I am going to factor out a 7/6. Okay, and I'd be left with the natural log of x plus 3 minus the natural log of x minus 3, like that. And then I'm going to use the quotient rule on these guys. Okay, so let's see, x plus 7, 6 times the natural log of, be this guy over that guy, x plus 3 over x minus 3 plus c. Certainly this is much more condensed than this up here, so certainly I like this guy a heck of a lot better. Now, do I want to go back into root form? Okay, well, if I bring this 7, 6 back, it's going to be the 6th root of everything to the 7th power, which means that it's not going to be in simplest radical form, which means I'm going to have to put it in simplest radical form. And I think, as we saw yesterday, that's just going to continue to muddy that up. You could go that route if you wanted to, but there's no reason to. I'd say this guy right here. I like this guy. Okay, I'd stay with that form of the answer right there. Okay. All right, let's do one more. Okay, let's see, very similar. Another pair of differences of squares. Okay, so again, we're going to have to do this long division, okay, and get this out of the form it's in. Okay, so let's see. I'm going to move this guy up. Okay, all right, so let's see again. I'm going to have to go x squared plus 0x minus 36, and then divide that into x squared plus 0x minus 100. Okay, so of course x squared divided by x squared is 1. Okay, so notice how similar this is going to be to the last one. Okay, and then we subtract. Okay, so x squared minus x squared is 0, 0 minus 0 is 0. Negative 100 minus a negative 36. That's going to give us a negative 64. Okay, so let's see. So this guy would be the same as the integral of 1 from right here plus the remainder, negative 64, over the divisor, x squared minus 36 dx. Okay. All right, so let's get this out of the way. I don't need that anymore. Okay, so again, I've got to go, attack this guy. So let's see. This is going to give me the integral of 1 dx, okay, plus the integral of negative 64 over, okay, x squared minus 36 dx. Okay, so let's see. The integral of 1 dx, okay, minus 64, just pulling out the constant multiplier, of 1 over, and then we factor the x squared minus 36, so that'd be x plus 6 times x minus 6 dx. Okay, so we know this is going to be real easy. That's no big deal. So here is where I have to use the partial fractions, right here. Okay, so I've got to go attack that guy. Okay, so let's see. We take this 1 over x plus 6 times x minus 6, and that is going to be equal to some constant a over x plus 6 plus some constant b over x minus 6. Once again, multiply through by x plus 6 times x minus 6 to get rid of the fractions, so everything cancels here. Over here, I get the x plus 6s to cancel, so I am left with a times x minus 6. Here I get the x minus 6s to cancel, so I'm left with b times x plus 6. Okay, so obviously we're going to let x equal 6, and that'll make this a 0, and then we'll let x equal negative 6, and that'll make that a 0. Okay, so when x equals 6, we get 1 equals a, that would be 0 times 0, okay, plus b, and let's see, 6 plus 6, that's 12. Okay, so this goes away, so we have 12b equals 1, so b is equal to 1/12. Okay, let's see. When x equals -6, we get a 1 equals a, let's see, that'd be -6 minus 6, so that's -12. Okay, plus b, and -6 plus 6 is 0. So that guy goes away, so I get -12a equals 1. So a is equal to -1/12. Okay, so let's get everything set up. Okay, coming back up here. All right, let's see. I have that integral of 1 dx minus 64. And again, I'm using all this down here to split this guy up. Okay, so that would be the integral of a, okay, which is -1/12, over, that was x plus 6 dx, plus the integral of, let's see, b, which is 1/12, all over x minus 6 dx. Okay, so we should be in good shape here. All right, let's move that guy up a little bit. Let's see what happens here. Okay, so clearly, okay, I can integrate this and I just get x. Okay, so that's no big deal. All right, so let's see, this guy right here being negative times a negative when I pull this constant multiplier out. Okay, so that's going to be plus. And let's see, 64 over 12. Let's see, if I divide them both by 4, okay, wouldn't that be, 64 goes into 4, what would that be, 16 times? Okay, yeah, so that'd be 16 over 3. Okay, 16 over 3 times the integral of 1 over x plus 6 dx. Okay, then let's see, we got a negative times a positive, so that's negative. And I pull this 1/12 out front with the 64, so 64 over 12, again, that reduces down to 16/3. Okay, and I'd have 1 over x minus 6 dx. Let's see, 64/12, so I want to make sure. Divide them both by 4. 64 divided by 4 is 16, right? And 12 divided by 4 is 3. Okay, we're good. Okay, we're in good shape. Okay, so let's see. This guy I just bring down, plus, okay, that's 16/3. Okay, and I'm going to let u equal x plus 6, so du is equal to dx. So I'm going to get the integral of 1 over u du. I'll bring that minus sign down. Okay, so let's see. In the 16/3, the integral of, if I let u equal x minus 6, then my du is equal to dx. So I get 1 over u du. Okay, so x plus 16/3. Let's see, the integral of 1 over u du is natural log of u, so that would be the natural log of u, and u is x plus 6. Minus 16/3. Once again, the integral of 1 over u du is natural log of u, so that's natural log of u, and u is x minus 6. Okay, so all we got to do is just finish this guy up, and we're good. Okay, notice it's just like the last one. Okay, I'm going to leave this x out front, and I'm going to factor out a 16/3. Okay, and so I'd end up with the natural log of x plus 6 minus the natural log of x minus 6 plus c. And then we use the quotient rule here. Okay, so x plus 16/3 times the natural log of, it would be x plus 6 over x minus 6. Plus my constant of integration. And again, I like this form of the answer. Okay, once again, if I bring this 16/3 back, notice that it's going to be the cubed root of everything to the 16th power, which means it's not in simplest radical form. And so when I go to put it in simplest radical form, it's just going to expand everything and make it more complex. So certainly I would go with this answer. I think this is the best form of the answer right there. Okay, so that wraps it up for today. I think we have 2 more problems to do tomorrow that are sort of like these guys just notched up a little bit. Okay, so we'll get to those tomorrow. And I should have the quiz posted sometime today, if not at the latest tomorrow. You guys stay safe out there, and I miss you a whole bunch.